All right, will do. Um, so I'll be going over a about-ish 10-minute presentation about C0 control codes. I'm not sure if everyone is familiar with Unix terminal, but just to repeat that this session is all about it seems like Unix utilities and tools mostly. And this is not directly linked to Unix terminal, but this is I think most of us have seen one way or another when we try to control C in Unix terminal, it doesn't quite copy, and we're strictly talking about actually here Unix, like native Unix type terminals and not necessarily Windows type terminals. And we'll be going over why Windows has actually implemented it so that these don't actually count on Windows machines most of the time. But that's going to be the topic of this 10-minute presentation. I'll be setting a timer so I don't make it too long. First of all, this is the ASCII table. I'm not sure how is it supposed to pronounce, but the picture itself here, this is the US ASCII code chart from 1972. It was shipped with Terminet 300. It's a terminal type machine that's seen on the right there. The copy paste itself, as we know, with the Control C, we know today was invented by Lawrence Gordon Tesler between the years 1973 and 76 at Xerox PARC. For those of you who don't know, this company where Apple actually stole the idea of a graphical computer environment, and Terminet and this ASCII table are very, very deeply associated with the Xerox PARC. That's the company. This ASCII chart here, the code chart, has however it's been around since the late 1960s, so it's definitely before the Apple, Windows, and all of those eras. And this is the history behind why the Control C is more dominant still in Unix systems rather than with the copy-paste type of feature. Many keyboards and computer terminals once directly actually generated the ASCII code. And just like I said before, this is the standard that was actually first based. Hence why this is still a thing in the modern Unix computers as well. The chart in the left corner is going to be brought up later in the presentation, so you don't need to actually memorize this, as we'll be going over this a bit more later in the presentation. This is let's see just the. I actually don't need to put up any poll on who has ever tried to copy paste like with Control C on a Linux terminal or Unix terminal. But anyway, the thing is, if you try to copy paste something in a Unix terminal, it most likely with Control C just tries to interrupt or exit the program rather than just copying and pasting. This is why the Control C sequence was actually designed by this US ASCII code chart to do the end of text, as you can see on the red line here. You see that the C actually corresponds to ETX, which is the end of text, which is the number 3. This is only because there's 4 binaries here, which we can describe this B section here, and there's I think this is a 3 binary 3 bits value from which we can actually choose it, and this was used in the 1960s computers, which is still in use of kind of the Unix terminals. So the why it's Control C and for example not Control B or Control X, which is like more closer to the human hand itself, is because it's just the number 3, which corresponds to ABC. This is C, end of text. That's it. It was designed as an interrupt, though to be unlikely a part of program's interactive interface. So it wasn't actually, as I mentioned before, to be used as a Control C like copy paste type thing, which was in the later generation, like 10 years ahead when the Xerox PARC computers came to And so that's the end of text. But there, because of this actually explains why the Control C doesn't work quite as like in the Windows terminals or anything like that, like copy paste. It's because of this code chart, and we can see that there are other codes that actually match up to these. For example, that there's the Control D. We can see from here, it's here. I think this is the end of. I can't recall what's it. Something like end of. You can actually shut down some programs with it, like exit from them. For example, I tried to manage to this day access the Glasgow Haskell compiler interactor, which is kind of like, for example, a Python shell is something which most of the people are more familiar with. You can't exit with Control C. You need to exit with Control D because that's the C0 code that it's actually giving there. Control M, I think it's let's see how it is here. M. CR, carriage return. So it acts actually like an enter. You can actually try this all out in your own Unix terminal. If you just write some command and press Ctrl M, because of this USASCII chart, it actually interprets it like a CR. And this is mostly, again, this is why Windows doesn't actually support this, because line changes in Windows are CRLF, which is line something and carriage return. Anyway, this is a Unix type thing, and thus it works with Control M. Control R is let's see what it says here, and because this is again a 3-bit value, it like kind of loops itself to the next section, which is here, the STX, or more likely DC2, which actually corresponds to in the Unix environment to a history. Most of you have used the history command or program before in the Unix. With that, you can check which kind of programs or commands have you entered lately. You can use this, but more interactive. It's much faster. If we have time, we can maybe demonstrate it either. The use case are interactive shells and remote connections to servers, where it could be a combination of foreign keyboard layouts when you can't even actually input the right letters. This is where the US ASCII code chart comes into a really handful use. So you can always rely on these working quite like it's intended to be, without having to worry about remote connections or foreign keyboard layouts. And for example, in the case of Control R, it's very handy. It's a shortcut, and most of these provide a very handy shortcut. And the use cases, the most important of them all might be the combination from the all above. Let's say that you're maybe like using a Kubernetes orchestration system that deploys many Docker, like multiple Docker images and containers, and you need to access them with a Tmux that have, say, maybe one of them could maybe imaginally use a Glasgow Haskell compiler interactive or some kind of Python shell or something else, and you need to exit them and manipulate. And you can almost always reassure yourself that the US ASCII chart actually works in every one of them without having to worry about these 4 aforementioned facts. And other reasons why this has value, it's useful also when troubleshooting other Unix systems or other systems overall, because for a better understanding, while this is good information about the modern Unix terminal, might sound a tad trivial, I think it's good to have a better understanding of the present, so we can, it's good to understand the past better so we can understand the present. So yeah, that's why. And I think that was all I had to say. We have only like minute and a half left, so it's good to skip a bit of sections. But here's an afterburner questions. There's 2 questions. You can check with your own Unix terminal what does Control G do on your Unix terminal. You can check the US ASCII chart. It's in Wikipedia, and I think it's somewhere else. And if you have the time, you can check on Can you think of three other C0 codes that you actually could implement into your daily workflow with the Unix terminal? These are very easy to, you can just check them out with your own Unix terminal and check how all of those work. And there's also the GNU manual for console codes that outputs which kind of uh, uh, codes actually work in the modern Unix terminals. Because, for example, with the logic of this chart, Control 3 should also do the end of text, which it doesn't in Unix terminals. I think they have also disabled it. But with this, you can check which codes actually work on the modern Unix terminals. We have 30 seconds left. I think we can stretch it a little bit, but for now, I would like to thank you for listening this presentation, and I hope you all have an excellent weekend.